Just a bit about me, my background. I'm going to walk you through kind of where I'm at right now and how I got there, which will hopefully give you a bit of a roadmap as to what you can do to kind of move up the ranks and be able to pivot to a data scientist role, especially if you're already currently in an analyst related position, whether it be a business analyst or a data analyst. So a bit about me. Right now I work as a data scientist at a company called RVZ. What RVZ does, basically Airbnb, but for RVs and motorhomes. So identical business model, same types of metrics we're looking at, and I help lead some AI-driven initiatives at the company. I also do some bootcamp instructing at Lighthouse Labs. I work at the University of Ottawa as an instructor, and in my past, I've worked in HR analytics and talent acquisition HR analytics, where I've had the chance to work with multiple publicly traded and public sector companies. A bit about how I got to my current position of a data scientist, as well as even teaching data science. It was a very long journey, so I tried to kind of lay it out on this slide as comprehensively as possible. So over around 7 years ago, I actually began my educational journey, my secondary educational journey in finance, where I spent 4 years just going through that. My initial inspiration was to work on Bay Street, Wall Street. I'm up here in Canada, so for us it's Bay Street, it's not Wall Street. But a few years into that journey, that kind of transitioned into wanting to move towards a data-oriented role. So in my second step, I kind of opted into co-op, which for those who are not aware, co-op allows you for certain universities, certain programs to have work terms during your degree to actually try and experiment being an intern in certain companies or public sector entities. So that's very helpful to have if you're looking for, let's say you're not at the graduate level yet and you're in the middle of an undergraduate program, you might want to look for one that allows you to actually hop into a co-op program. So it'll give you some work experience, which allows you to see what you do and don't like. It might give you the ability to have a full-time job waiting for you at graduation. Now, through this co-op program, I first went through 2 public sector roles. And then beyond that, at this point, I also transitioned into a private role working in consulting. But after these 3 internships, I still had little to no data experience at the time. So what was my approach to actually getting my first data job? Because that's the biggest obstacle that we typically tend to see is you'll go on a job posting or you'll see a job description and it'll say in order for you to kind of apply to this entry level data analyst job or analyst job, you already need 2 to 3 years of experience. So it's a bit of a feedback loop where you need the experience to actually get the analyst role, to be able to level up, to become a data scientist. So in my case, I actually did something completely off the cuff, which again, I recommend depending on where you're coming from or how you're trying to position yourself. I actually took a sales job within an HR analytics startup with the full intention of working that role as well as I can in order to keep tapping on the shoulders of the data team to see if they needed any extra resources, any extra help. And slowly but surely, I was able to kind of break down the manager at the time and eventually get a spot for my last co-op at that startup. So I transitioned to a sales role where it wasn't actually what I was intending on staying for. I was able to kind of pivot and get a shot, a trial from the data team to see if I could be a good fit there. As soon as I was able to land that, I spent my 4 months doing that co-op, which kind of terminated the end of my finance degree. And from there, kind of the rest is history. I spent over 5 years at that startup. And that startup, again, specialized in doing HR analytics for publicly traded companies. So I had the opportunity to understand from an A to Z standpoint, how do you actually source data? What are all the different barriers and obstacles involved in sourcing it and protecting it? What are the different layers of ethics when it comes to data collection and storage? So I kind of saw that process through for 2 to 3 years as an analyst, junior to like medium intermediate level. At my 3rd year at that company, I became a senior data analyst, where I now started managing other data analysts. And what you'll notice is right now, if you're in a junior to intermediate analyst role, if you try to become a senior analyst, it's actually a great way, a great pathway to becoming a data scientist. And the reason why is it allows you to master a lot of the skills that you're going to have to use day to day. So if you have the opportunity to level up to become a senior data analyst and manage other analysts, it takes you from being great or good at certain tasks and roles, which we'll go through in the next couple slides, to kind of having mastery. And that mastery will allow you to make that natural progression to becoming a data scientist. Now, on top of actually trying to take that sales job on, I attended many meetups, and if you're not aware with what meetups are, it's basically this app that allows you to attend networking sessions for the most part that are free. So I attended every single one in my area, which is Ottawa, Canada, that were data oriented in nature. Now with the pandemic, now in person is now kind of coming back into the spotlight, but there are a lot of options like this session that you're watching right now, which are remote. So given the fact that traffic and transportation is no longer a barrier to attend conferences like these, one of my biggest recommendations would be to continue attending as many of these as possible. The next ones is something very actionable you can do. If you're not aware of this application called Slack, it's like a messaging software. If you download this software, there's a lot of groups you can join. They're like open groups where everyone's trying to help each other. Some beginners, some medium level in terms of experienced analysts, and very advanced data scientists. So 3 specific ones that are free and open to join are 1, Data Talks, 2, Open Data Science, and 3, Locally Optimistic. So these 3, you'll see people from all ranges of domains and expertise that all try to give each other tips with absolutely no tangible benefits, just everyone helping each other as a community. So given we're living in an online first world right now, these are 3 great approaches that I recommend even today. Now, to skip towards my 6th kind of point there. So after working as a data analyst for 3 years, became a senior data analyst. I worked in that role for 2 years, and then I had to make a decision, which is kind of what this session is really motivated by. How do I get from being a senior data analyst to becoming a data scientist? What's it going to take for me to be able to upskill, to be able to get to that next level? After a lot of deliberation, I actually went the route of the self-teaching route. So I did a lot of online open courseware, online courses, and then I got myself to a certain point where I was pretty good at programming, decent at the maths you need for machine learning and AI. But at some point, I needed some form of mastery, and I wanted some in-person experience, also to be around others in the domain who are maybe more senior to me, to possibly be my mentor, or to learn what they're doing day to day in their jobs. The issue with always doing online courses for me is that I tend to spin a bit or spend too much time working on certain courses, or take kind of signing up for so many courses, not finishing them all, which is one of the biggest obstacles that I see with online courseware. But it's an option. For me at the time, it wasn't the best one. So I did a Master of Management in AI at a university called Queen's University here in Canada. And then last but not least, I was able to transition shortly after completing this degree, having done all those projects, worked with some publicly traded companies throughout my master's degree, and doing my thesis in venture capital predictions for successful companies. I was able to pivot to working as a data scientist at the current company I work for, which is RDZ. And then beyond that, now I started instructing at universities to be able to kind of keep myself current in the field and continue my advancements there. But that's a bit about my journey. Hopefully it shows that it's not necessarily linear. A lot of times you look at someone's LinkedIn and you'll see, oh, you did an undergrad in computer science, a master's in mathematics or statistics, and you see that they became a data scientist right away. So you kind of see that linear progression. A lot of times from what I've seen, there's a path that's a lot harder, but it's still possible to get there, which is the path that I took. Now, if we want to quickly step back for a moment and just differentiate between what is a data analyst versus a data scientist, what's the key differences here? So in the first one, when we talk about high-level job descriptions, what a data analyst typically does is a lot of the data collection, possibly the transforming of that data to increase the data integrity, increase the visibility of data across an organization or a team. And then they try to leverage tools like Power BI, Tableau to create visualizations from basic to stunning, depending on the requirements. And obviously, when it comes to manipulating the data, they become the experts at that. the core difference between the job typically is there's many versions of the definition of a data scientist. Slowly but surely, the kind of framework for what is a data scientist versus a data analyst is becoming more siloed and more properly separated. But in general, a data scientist goes the extra mile, where they don't necessarily collect and manipulate that data, but they use that clean data or that manipulated data to actually build advanced models, predictive models, AI-driven models. And one of the core roles that I take on is to try to stay as current as possible with new programming frameworks, new softwares to try to make things as efficient as possible, and other new tech on the horizon. From a day-to-day perspective, the only core difference is that you have that modeling aspect, and in some cases, you take on different hats as a data scientist. One, for example, that you might not foresee is actually doing something called data modeling. If you don't have a data engineer in a company or organization, typically a data engineer does all the connecting to different data sources to build this bridge where you're able to kind of absorb that data, transform it, and then find some way to actually create a data source from it. In lieu of actually having a data engineer, the data scientist sometimes can take on that role or becomes part of that role. Also, when it comes to something called being a data steward, the data analyst typically takes on this data steward role, which involves creating what we call data dictionaries. And what a data dictionary is let's say it's a series of columns and rows. This data dictionary tries to break down what each and every column actually means in English. This is the field name, this is what data it contains, this is what data type it has, and then the last one is maybe a bit of a description as to what values exist within these columns. So they try to give a lot of the foundational work, documentation, so that you can actually scale incrementally as an organization. And then some of the major differences here at the very bottom of my slide is one requires a mastery in coding and database languages, which is obviously on the data scientist side. You're going to see here that a prerequisite is a master's or a PhD. With this one specifically, as I'll touch on in this session, you don't necessarily need a master's anymore. For some roles, you'll still see master's preferred, PhD preferred. It really depends on where you're going. Typically, your best bet for kind of landing that data scientist role as an analyst is looking at startups where they're more able and flexible to invest in you as an analyst to kind of level you up to become that data scientist. But the major thing here is that there's a level of mastery in coding, not just in R and Python, but a big one is SQL, which stands for Standard Querying Language, which is just a database language that's used to try and ask questions of your database and pull relevant information. And the last one here I'll touch on is the skills. So the biggest skill, the biggest leap that you take from being an analyst to becoming a data scientist is you're tackling very ambiguous problems. You'll be asked a question that's very open-ended, where it's not as defined as some of the questions you'll tackle as a data analyst. So for example, as a data analyst, you could be asked, can we see the distribution of sales over the last 3 to 4 quarters? As a data scientist, you'll be asked, what would it take to get to 10 times our current revenue? Notice the difference in the scope of those two questions. One is pretty actionable right away. You can just go to your database or your data source, could be in Excel, could be in the cloud, and find your last 3 or 4 quarters worth of data on sales and try to filter to see the distribution of that sales. The other one is kind of like a blank canvas. And the tricky part of being a data scientist is that this blank canvas allows you to have kind of a myriad of paths to take in terms of that analysis. So it's really the mastery in the analyst role that allows you to be the best data scientist you can be, because you can become more familiar with different ways you can tackle a problem and why you'd want to tackle it one way versus another, either in terms of cost of time or actual budgetary cost. In terms of paths to data science, I would usually say that there are 3 core paths. One is self-teaching, which I'll touch on in my next slide. Next is formal education. This is typically what we're used to, going to university or college and then pursuing an undergraduate degree, and then from there maybe to pursue a master's and kind of going down that linear progression. Nowadays, with kind of intensified competition in the world, especially the fact that many of us are remote now with access to free information through the YouTubes of the world to other pieces of information which are all offered online, the prerequisite for formal education is becoming less and less relevant and less required from what I see in the field. And last one is in-role upskilling. This is probably the easiest way to change and progress from just being an analyst to being in a data science domain. So some examples of tooling when it comes to self-teaching are kind of 5 key things to think about. And each one of these will add to your repertoire of data science. So the first one is, let's say you want to just dabble and kind of poke your head in and see what's available in the data science world, what interests you. There's not just one specific stream within data science, there's multiple. You can go down the descriptive route where you're doing analytics, just talking about what happened yesterday. You can go down the prescriptive route where it's not only what happened yesterday, but what should happen tomorrow and how do you actually plan on getting there, what do you need to get there. And then you have others such as predictive, which is maybe not necessarily telling me how we're going to get there, but what's a year from now going to look like in terms of 1, 2, 3 metrics. So one thing you can do here is open courseware. One example is the Harvard edX, where you can kind of log in, create an account, and take a series of courses all for free at a pretty good quality and be able to gauge, is this interesting to you or not? Is being a data scientist really much better for you and what interests you versus being an analyst? The next one is maybe from there you take one level further. You go to low-cost online courses. There's all kinds. There's ones called Skillshare. The one example I'll give here is Udemy. Udemy allows you to take a course for pretty much a fraction of what you would, let's say, a university, a formal education university, and allows you to kind of focus on specific skill sets and specific projects that you can do and code along with an instructor. From there, there's another progression. Again, there's an increase in commitment, an increase in cost, but still negligible compared to what you do to do a typical degree. The next one would be an example as Coursera. So Coursera has courses just like Udemy and Skillshare, but what they do that's a little bit different is that they have much larger scope self-guided projects. So basically you have a pre-recorded session of an instructor laying out what needs to be done in a project, and you kind of work at your own pace to finish that project incrementally, getting some help along the way if you need to. So this allows you to not only just consume information like you are right now in this conference, but also take it in and actually apply it as much as possible. The last example here in terms of just core information would be books and Medium articles. So if you're not familiar with what Medium is basically an aggregator of online content. It has a community called Towards Data Science. Over the past 5 to 7 years, this has kind of exploded, and typically very experienced people in the field, whether it be data analysts, data scientists, or engineers, they actually take the time to walk you through a project that they started from beginning to end, walk you through their methodology, as well as some of the algorithms they used, and sometimes they even throw their code there just to help others upskill and learn. So if I share my, sharing my screen here, if you can see this article, just to show you, this is an example of a Medium article where if you go down here, it'll give you a bit of a list of how to become a data scientist in 12 months. Another example of an article is here, how to become a data scientist, a detailed step-by-step guide. So typically you get a few free articles per month, and as I scroll down, you'll see a very explicit breakdown of what data science is, what are data scientists, what do they do, and a lot of times you'll find some stunning visuals used by these authors to get their points across. And especially as we progress to looking at building projects, and you start Googling things like how to build a weather predictor, and you go on Medium, you'll usually find someone that's tackled that specific project before, and you can start to read and get inspired by the methodology they adopted to be able to do that. The final thing here that you can do in a self-teaching environment, if you go down this route, is competing in something called Kaggle. Kaggle is this open source community where it offers open data sets. That's number one. So if you actually want to tinker rather with using real world data or subsets of real world data to practice, whether it be data visualization, actual Python or predictive analysis, it'll give you quite a few free data sets to play around with. And if you want to go to the next step, you'll be able to actually compete in competitions against others all across the world to optimize for something or write a piece of code to try to predict something like fraud or no fraud. So it has quite a few competitions within its domain. And if I could actually show you a bit of a glimpse here, you'll get an idea for what it looks like. So let me know if you can't see my screen, but if you can see here, you'll see that they show you all these the data sets here. All of these you can download pretty much for free. If you go on filters and you go on, let's say CSV, and you click apply, you'll see that you get quite a few very popular data sets. You can click on one, and then if it wasn't used in a competition for whatever reason, you can actually click on code and start to see what others have done to answer the original premise of this project. They'll walk you through their approach, and they'll give you all the code that they did to actually solve this project. If you don't want that, you can just use the data itself by downloading it, and you can go from there and do your own analysis if you wish to. So those are 5 key tools, 5 key, what I say are weapons to be able to become very dangerous in the data science domain without necessarily breaking the bank to actually do a formal degree. Now, if I were to give you a recommendation based on going both paths, I've done the self-teaching path, I've also done the formal education path. Each has its pros and cons. If, first of all, in-person is still not an option in the area that you're in, then it's pretty much kind of made for you, that decision, in which case this is a very relevant slide. So if I had to recommend a recipe for kind of giving yourself a good start to becoming a data scientist from a data analyst, first I would maybe recommend you look at one free open course. So there's all kinds of universities, not just Harvard. I think there's also Yale. I think there's also Berkeley. All offer free open courseware. Kind of take one, see if it interests you, see if you can actually finish the course end to end. Typically, that's a good gauge for whether or not you actually are interested in making that pivot from an analyst to a data scientist. If that goes well, then maybe consider getting 4 paid low-cost courses from any provider you wish. In terms of core skills, the ones I'd recommend, I have one repeated here twice for emphasis. So Excel, Power BI, Tableau, Power BI, and SQL. That's not because of a personal bias to a tool, but typically, if the company you're working with uses a Microsoft stack, then if you learn Excel to a very good degree, like advanced or even intermediate, Power BI is a visualization tool that works hand in hand with Excel. So those two together would be very powerful. Another is you want to kind of gauge, let's say you have a vision for where you want to work, or if you want to pivot from your role at your current company, if you don't have one right now, to a role where they're using Tableau, then it's useful to be aware of that, because you'll see down the line from job description to job description, employers now start asking for not just knowledge in one, but in both. Why? Maybe 2 to 3 years while using one of these tools, they decide that they want to pivot to another one. Ideally, they want someone that's had that, been there, done that experience with at least understanding how to manipulate using that tool. So both Tableau and Power BI would both be very useful. The one that I'm highlighting here in green is kind of a core skill that really differentiates you as a rock star compared to a normal data analyst. As a data analyst, you don't necessarily code very much, or if you do, it's very sparingly. Especially when it comes to databases and SQL and pulling data, it's typically very minimal what you're doing, or very simple queries. If you actually go to the extent of becoming intermediate or advanced at SQL, it doesn't have to be the Microsoft SQL, it could be Postgres SQL, it could be NoSQL, but at least understanding how that works, it really differentiates you as a candidate, and it allows you to do much more in-depth analysis on your own versus having to rely on data engineers and data analysts and data scientists to supplement your work to be able to make that possible. So if you actually become a master SQL, it's my personal opinion that it really advances you in being able to do this transition from an analyst to a data science role. Next, to supplement this would be two more things. One would be maybe 2 online courses with self-guided projects. So let's say you go through those courses, the open course ones and the low cost ones, and you still have that momentum to keep going. I would add possibly 2 online courses with self-guided projects, especially if you're trying to look at not just becoming a data scientist who's able to better manipulate data than a data analyst, but one who's also able to start using predictive machine learning and statistical frameworks to actually do that analysis. So doing this will definitely help you to actually apply this, and as I'll show you in the next slide, be able to exhibit experience and proof of that experience. The last one here is, I'd say it's very optional. So let's say you're designing your resume in a way where it's not just showing all your self-teaching experience, but also you do want that official certificate from a university or a renowned college, but you don't want to pay for that degree the same you did for maybe an undergraduate degree or a master's degree. There are such things called certificate programs. What a certificate program allows you to do is do a lot of the learning over a shorter amount of time, could be a month, 2 months, 3 months, 6 months, and pay a marginal cost based on a whole, couple of years worth of tuition. And you still get that certificate, something you can put on your resume if you want something to stand out in your education section, separated from your additional experience or additional education section. Once you go down this route, let's say you actually do the projects either through self-guided courseware or through your own means. Actually, you put together a portfolio of your projects done and the work you've done online from these courses. The next recommendation is, how do you go to show an employer this next step if you aren't looking to rise within your current company? The next thing you could do here is just post your work on an open source repository called GitHub. What GitHub allows you to do is upload all your code, whether it be Python, SQL. You can even upload Excel files if you wish, and Tableau files, Power BI files, to start to create this folder and portfolio of work that you've done in data science. So typically, when I'm hiring data analysts or data scientists, I actually look for, if you haven't had experience as a data scientist before or an intermediate data analyst, if you have a couple links to your GitHub where I can take a look at projects you've done, I can start to get an understanding for, one, it seems that this candidate has an inspiration for data science, has this need and want to actually break into the field. It shows me that initiative. The next thing it shows me is your coding style and your writing style, as well as your possible data manipulation style. It gives me a gauge for, okay, you took a course, but did you actually consume and digest what was in that course? So that becomes a very useful tool for yourself to be able to present yourself in front of an employer or other colleagues to show them that you actually are very serious about breaking into this industry. The second option here is a bit of a subset of the first. So there's a lot of recommendations around creating your own website for resumes, and I'd say there's no exception when it comes to data science. So if you don't want to host your projects on a GitHub, because maybe you don't want to be like everyone else who is also using a GitHub right now, if you post your projects as, let's say, thumbnails on your personal website, with each explaining the context of the project, the methodology you approached, the technology you used, and the conclusions and insights you had, these two things can really differentiate you from a resume perspective as an analyst candidate. Now, the formal education stream. So we're done with the self-teaching stream. If you want to go down the route of formal education, there's a couple kind of key degrees that pop up over and over again from what I've seen when hiring in the field and also working in the field. So one is obviously mathematics. If you have this foundation, it typically allows you to transition much more easily to a data scientist role. Because when it comes to predictive analysis, there's a lot of understanding and interpreting mathematical results. Another one is commonly computer science. So this one really depends on which type of data science role you're going for. If you're going for the more technical ones, the maybe machine learning engineer, the data scientist that's kind of using very mathematical based methodologies, this will be very much helpful, especially if you want to build both software and data science products together. The next one is maybe a bachelor or a master of data science. 7 years ago, this didn't exist. So had it existed, then I would have probably pivoted into it right away. But now you have bachelor's degrees at various universities, offered online as well as master's degrees in data science. So these programs are designed to give you as much of a comprehensive look in the field and the different tooling you need as possible. Similarly, my colleagues at my work also have done a bachelor's or a master's in analytics. This is offered separate from data science. Analytics and data science are pretty much one of the other. So analytics rather is kind of lumped in under the umbrella of data science, but this specific degree just focuses on descriptive and prescriptive analytics using maybe the data visualization tools, data collection methodologies, and other frameworks. The last two I'll zero in on are data analytics engineering. So an analytics engineer is what I was referring to before, a data engineer. It's the person that builds that bridge between where the data lives and where you want it to live and how you want it to be stored as well as cleaned. And the last one, very common one, is statistics. Because data science involves all kinds of distributions and stats, typically it's a great degree to pursue if you're going through formal education to build your chops in understanding what it means to have a normal distribution, what it means to have a mean, median, and mode, and the effect they have if one is larger than the other. Understanding data from a much more statistical standpoint. This last one that'll kind of sum up our short session here is talking about in-role upskilling. One of the easiest ways to become a data scientist if you're in an analyst role is actually kind of promoting yourself from within. And I'll give you some more feedback on that. Having hired externally, I can tell you that the cost to hire and the hours spent interviewing candidates exceeds probably 5-6 days of my time, manager's time, and colleagues' time, because you have multiple levels of email chains being generated, as well as interview rounds that happen that kind of allow you to see so many candidates, but not necessarily select all of them. So it's our advantage for someone who's an analyst to kind of express interest that they want to become a data scientist. And we can try to invest in them as much as possible, because it'll be much cheaper for us to have someone who's already acquainted with our data and acquainted with how we do things in our company structure and data source locations than bring in someone fresh to onboard them on everything and have to wait a month, 2 months before we can actually activate them as a data scientist. So some examples of different methodologies and approaches you can take to kind of convince stakeholders, colleagues, or your direct report that this might be a great option for you is sometimes ask to create stretch tasks. So let's say you're just asked to generate a graph or a series of graphs or a dashboard or pull a query. Maybe you ask, if you finish that work early, are you able to go that next step further and start to experiment and tinker with different methodologies or tinker with different algorithms to see if you can push your analysis one step further. And if you do this over and over again, you'll start to really grow that data science skill set. The last couple here is offering after-hour support of the data team. So let's say you're working, in my example I did at the very beginning, in a sales job, and you're trying to find some way to break into the data team, kind of move laterally within the company. Try and see if you want to offer free services to help or support the data team in any way. There's always tons of work that we don't necessarily want to do that's maybe more admin in nature, that maybe you could take on as an individual from a different function in the company or organization. So that might be one thing to think about. It sometimes can feel a bit drastic, but if you're really passionate about this, there's multiple ways to be able to break into it. The last two that I'll touch on is investigating whether a lifelong learning budget is possible or available. So why not combine self-teaching with this in-role upskilling? if you're already an analyst and you work for a company, why not ask them if they're willing to pay for a couple of the low-cost courses? And especially if you express interest into how that will actionably be able to make you a better analyst and possibly a data scientist within the team. If you have that kind of business case as to why it's worth the investment, typically these courses can range from $10 to $100. So given that many companies can expense this as an education expense, it might be possible for you to upskill not just from shadowing others, but also from actually taking online courses while you're doing your day job. Which leads to my very last point here, which is expressing interest in shadowing data scientists or data engineers. This is something that I'm used to from all the companies I've worked in. We like to shadow other functions to better understand what their pain points are. Especially when I worked as a data analyst, one of my biggest concerns was understanding from different companies and stakeholders in those companies, what is the reason why data is hard? Why is analytics hard within their domain? And shadowing what they do day to day gave me that appreciation for the different roadblocks and obstacles that they face in being able to implement analytics. The same thing is true when it comes to data analysis and data science. If you just ask to even hop on the daily stand-ups or the weekly stand-ups of the data scientist team or data engineer team, you can start to hear and better understand the way they think, the way they approach problems, and kind of digest and consume that mentality and mindset. Because the skills and the skill set and using the tools is one thing, and the mindset of a data scientist, especially when you're tackling ambiguous big problems, is another thing. So with that, hopefully that was a quick, succinct, informational session on being able to do that transition, and hopefully that's proven to give you some form of utility in your journeys. So I wish you the best of luck, and I'll open it up to questions if there are any.
Yeah, thank you, Marwan. Yeah, we have a questions. Let me read the first. As we move more and more into low-code, no-code environments, is knowledge in data science becoming more needed than general computer science, especially as data is more and more important every day?
Yeah, that's a fantastic question. So there's a great point just to clarify for the rest of the audience that typically, let's say 10 years ago, we didn't even have libraries when it came to things like Python. So these libraries have now emerged, and there's a lot of drag and drop even machine learning tools out there. So the need to be an incredible programmer is way less. The major difference is the need for interpretation. So what you need is the ability and the skill set to be able to look at an output of a number, an output of a model, and be able to explain what that's doing behind the scenes. Especially if it's low code environment, there's a lot of black box work being done behind the scenes. So you just need the proper education and the proper experience to look at a result or a conclusion or a stat and be able to explain to anyone, whether they're data savvy or not, what's actually happening behind the scenes. So that's kind of the mastery concept versus necessarily being an incredible programmer.